Hi guys, welcome to the today's session of design and analysis of algorithms. In this session, we are going to discuss about Kruskals algorithm of module 10. Now, Kruskals algorithm is used to find the minimum cost spanning tree for a connected weight graph. The main target of this algorithm is to find the subset of edges by using which we can traverse every vertex of the graph. This algorithm follows greedy approach to find the optimal solution. And this algorithm uses disjoint sets, union and find operations on disjoint sets to find the minimum cost spanning tree. So for that, first we are going to know about what are the disjoint sets, what are the union and find operations. So what is a disjoint set? If I am taking two sets are said to be disjoint sets if they have no common elements. If they have no common elements, then I can say that those two sets as disjoint sets. That is, the intersection of disjoint sets is an empty set. So here you can see an example. Here I have a set S which contains the elements from 1 to 10. So this set can be partitioned into, I want to partition this into 3 disjoint sets. Now here you can see the subset S1 which contains the elements 1, 7, 8, 9, the subset S2 which contains the elements 2, 5, 10, and the subset S3 which contains the elements 3, 4, 6. So in general, the disjoint sets can be represented by using trees in which the arc is pointed towards the parent. Now here you can see first set, one is, here I am taking 1 as the parent. So here, when you are representing a disjoint set in the form of a tree, you can use any of the element as the parent. Now here I am representing 1 as the parent. Now 7, 8, 9 becomes the childs and whose arc is pointed towards the parent. In the second set, I have taken 5 as the parent. 2 and 10 becomes the childs. In the third set, I have taken 3 as the parent. 4 and 6 becomes the childs. Right. Coming to the operations on disjoint sets, there are a lot of operations can be implemented on disjoint sets. The two operations that can be considered in Kruskals algorithm are union and find operations. Now, let us see what about this union and find operations. Right. Now, union operation means if Si and Sj are two disjoint sets, let us say here Si is one subset, one set, and Sj is another set. Now, if these two are two disjoint sets, then the union of these two disjoint sets can be written as Si union Sj. So, which can be represented as another set which contains an element X. Here, X belongs to either Si or X may belongs to either Sj, either Sj, right? So this is to be called as union operation. Now, coming to the find operation, given the element I, it finds the root node of the set containing the element I. It finds the root node of the set containing the element I, right? Now, suppose for example, if I return find of 9 in the first subset. In this first subset, if I return find of 9 means here I is 9. It finds the root node of the I, right? Now here I is an element in the tree whose its root node is 1. So this find operation returns the root node of 9, right? So this is to be called as a find operation. Now we are going to see Kruskals algorithm. So here I am going to play a small video which shows the steps in Kruskals algorithm. Try to understand it. Later we can discuss about that Kruskals algorithm. Right. the video is completed. So finally, for the given graph, he find minimum cost spanning tree using Kruskals. Now we will see the step-by-step procedure for Kruskals algorithm. So first we need to sort the graph edges with respect to their weights in such a way that the minimum weight edge is present at the first and the maximum weight edge is present at the last. That is, we need to arrange the costs in the increasing order. So start adding edges to the minimum cost spanning tree from the edge with the smallest weight until the edge of the largest weight. So first we need to start adding the edges from minimum to the minimum cost. Initially we take an empty minimum cost spanning tree. So first we need to add the edge. One edge we need to add. That edge should be a minimum cost spanning tree. So after adding that edge, next we will take another minimum cost edge. So we need to add the edges which doesn't form the cycles. That condition should be checked when we are adding the edges. Right. Now here the time complexity of Kruskals algorithm is big O of E log V or big O of V log V. Here E is the number of edges and V is the number of vertices. Now we can see an example how Kruskals algorithm works. Now here this is the given graph. So here you are given a graph. This is the given graph. For this graph I want to find the minimum cost spanning tree. So here I have created a heap out of costs of edges. Now here I have written AB with edge 1, AC with edge 7, and AD with edge 10, and we have AE with edge 5, BC 3, CD 4, and DE 2. Now first what I need to do, I need to arrange the edges in such a way that their cost is in the increasing order. Now we arrange all the edges in such a way that their cost is in the increasing order. So we need to first add a minimum cost edge. So what is the first minimum cost edge? AB is the first minimum cost edge. So we added AB to the minimum cost spanning tree. Next we will select next minimum cost edge DE. Now when before going to add this DE into my minimum cost spanning tree, first I need to check whether this DE, by adding this DE, it creates a cycle or not. Right. Since D and E, these both vertices are not included till now. So that's why DE doesn't create any cycles. So I'm adding DE to the minimum cost spanning tree. Now we are considering next minimum cost edge, which is BC. This also not creates any cycle. So that's why we are adding BC in the next step. Now the next minimum cost edge is CD. This is also not creating any cycle. So that's why we are adding CD also. So now let us see all the edges, all the vertices which are present in the given graph are added. So this gives finally the minimum cost spanning tree, and whose minimum cost is 10. So what the difference you observe for Prim's algorithm and Kruskals algorithm? So here the difference between Prim's and Kruskals algorithm is Prim's starts with a vertex and it goes for adding the vertices one by one based on the minimum cost. But Kruskals starts with adding an edge. It goes for adding the edges. Right. So Prim's is a vertex-based process, whereas Kruskals is edge-based process. And Prim's, in case of Prim's, there is a connectivity. So the next edge is selected, the next vertex is selected based on the edges which are incident on already inserted vertices. But here that is not happening. First we selected AB, next we selected DE. There is no connectivity of selection. So here these two vertices are not connected to these two vertices. So those two are the main differences between Prim's and Kruskals. Right. So I hope that you all understood the Prim's algorithm as well as Kruskals algorithm. Thank you for listening.